Two blocks connected by a rope of negligible mass are being dragged by a horizontal force F. Suppose that F equals 68 Newton, M1 equals 12 kg, M2 equals 18 kg, and the coefficient of connect friction between each block and the surface is 0.1. A. Draw a free body diagram for each block. B. Determine the tension T and the magnitude of the acceleration for the system.
Chapter 45.
So this is an original picture from the textbook. You can see the system here, two blocks connected together. There's a tension between two blocks, and there's a force someone is pulling from this direction. So for the question A, we can draw the first one for M1 here. You can see as a block here, there's a gravity. Of course, everyone knows that pointing to the downwards. So to keep it remain the same condition, there should be a normal force point upwards. And also there's a tension from this one. You can see there's tension. So tension point to the right. So also there's a friction point to the left. So for the second one, you can see there's still the normal force point upwards, the gravity point to downwards, the pulling force like here. From here, there's someone pulling the blocks. Is here, and also, but this time the tension is not the direction as the first one, because the tension this time is like a force to stop the blocks, and also there is a friction here. So here's the given: F equals 68 Newton, M1 equals 12 kg, M2 equals 18 kg. The coefficient is 0.1. So then we got find the tension T and the acceleration A. For block number 2, there is only 3 forces on the horizontal. The first one is the force that we are pulling. The second one is the tension, and then there is a friction. So basically, from A we know that they have a relationship like this: F minus T minus mu mg equals ma2. So for block number 1, it's a lot easier. There are only like 2 forces on the horizontal. The one is tension, another one is friction. So we got a relationship like that. The tension minus the friction equals ma, which from the Newton's second law. So for the whole system, we can get the force minus the friction equals the mass times the acceleration. Since this is the whole system, the total friction here is equal to mu times the total mass, which is m1 plus m2 times g, equals the total mass times the acceleration. So together, acceleration, we can divide m1 plus m2 both sides. You can see here. And then we got acceleration is equal to the force over the total mass minus the friction. So we can plug in the number. See, 68 Newton over 12 kg plus 18 kg minus 0.1 times 9.8. So then we can get the acceleration is 1.2 meter per second squared. For the tension, we can use the relationship from the block 1. The tension is equal to the m1 times acceleration plus the coefficient friction times the m1 times gravity. So plug in the number, we got 12 kg plus the 0.1 times the 12 kg times 9.8. We got the number is 27.2